Okay, we have finished discussing about the kernel-based neighborhood processing. Okay, and again I will like to highlight this diagram. Okay, we have finished discuss about the smoothing and sharpening operation, which is the two main operation that have been categorized under this kernel-based neighborhood processing. And then in smoothing, we discuss about two type of filter, which is averaging filter and Gaussian filter. While in sharpening, we talk about two main sharpening operation, which is the typical sharpening operation, which involve the high pass filter, or also known as the Laplacian filter, which is a combined with all pass filter in order for you to produce the sharpened image. And another alternative sharpening operation, which is called unsharp masking and high boost filtering. Now let's focus on another type of neighborhood processing, which is a non-kernel based neighborhood processing. Okay, in this process, what is the difference between a kernel and non-kernel? As what you see in the name of the operation, for non-kernel based actually is not involve a kernels in performing the operation. Of course, when we talk about another name for non-kernel based processing is also known as a non-linear filtering, which is I mentioned earlier. Okay, non-linear filtering. Okay, so why this operation is not known as a non-kernel? Again, because you don't have any involvement of kernels. Okay, no kernels. So without kernels means that of course there's no filter coefficient, because when we talk about kernel is actually we talk about filter coefficient, because anything with filter coefficient for sure that is kernel. So no filter coefficient in doing the operation. And then again, like I said, when we talk about the filter coefficient and kernels, it involve convolution. So in this mechanism, there's no convolution involved. So no convolution involved. And of course, if no convolution involved, which also means there's no SOP, there's no sum of product operation. Okay, SOP is represent sum of product that we have discussed earlier in kernel based. When we talk about convolution, actually the operation, the mathematical operation is involve sum of product. So in non-kernel based operation, since there's no kernel, means that there's no filter coefficient, there's no convolution operation, and since there's no convolution operation, for sure there's no sum of product mechanism. Okay, so this is the example of non-kernel based operation, which is median, mean, and maximum filter. Okay, among these three, the one that is very dominant is this one, median filter. Okay, we will discuss in the slide later. So let's go back to our slide. Okay, so I already discussed about this thing. Okay, meaning that non-kernels meaning non-kernel based neighborhood processing actually means no kernel, no filter coefficient. So no kernel is needed to compute the operations, and then also known as a non-linear filtering. Okay, if you in kernel based neighborhood processing, that is the name for that operation is also it is also called as a linear filtering process, or linear filtering, while this one is a non-linear filtering. And then one of the example of non-kernel based processing is also known as a order statistic filter. So why they call it order statistic filter? Because we already give you some examples there, because the name for the filter is minimum, maximum, as well as median, which is also known as a order statistic filter. Okay, because that is the idea of that this operation is come from statistical operation, where you familiar in when you learn the statistical statistic. Okay, when you learn statistic. Okay, so let's just go to the example for you to see clearly how does this non-kernel based operation works. Okay, this is the example of median filter. So if you can see from the example over here, okay, for example, this is your input image. Okay, this is your input image. Again, this is your fxy. Okay, so to obtain the output image, which is our gxy over here, then what is how to operate this median filter. Okay, you still need to have some window here, so that's why there's a windows there. Okay, this window, but there's no kernel, so that's why now you can see that this operation we don't have any filter, or we don't have any kernels like the like the one that we learned previously. Okay, in previously, to get our G we need our W, which is our kernels, but now in a non-kernel base such as median filter, we don't need this one, but we still need something like our window, where actually this window, what did this window do? If you talk about the median filter, you need to collect all these item inside the one that overlap with this window, and then you need to sort the number according to ascending order. Okay, this is I think this is very common for you, because when you learn statistics, when you want to find a median, the median number from the collected set of image, collected a set of numbers, when you want to find a median, then you need to sort it into ascending order. Then you just select the center value, okay, the number which is at the center. So we do in median filter, we do the same. Okay, meaning that we just collect a set of number, or a set of pixels there that overlap with this window, and then we sort into ascending order like this, and then we choose a median value. Okay, this median value we will transfer to the output pixels. Okay, so then you need to repeat again. Okay, like the kernel based filtering, where you need to slide the window. So you need to slide to here, sorry, and then you repeat the same operation. You need to collect all this number overlap with this green box here, and then you need to sort it into ascending order. Then you choose the median numbers to be put here, and again the border pixel will be set into 0. Okay, like what we have learned before. Okay, then you need to repeat again to find this one and this one. So that's how you do the median filter. Okay, so what is the advantage of median filter? Actually, median filter is a special filter which can tackle one special noise which is called salt and pepper noise. So what is salt and pepper noise? Okay, this is the example of salt and pepper noise. Okay, as you can see in these pictures over here, okay, it consists of white dot and black dot. Okay, the size of that dot is a size of a pixels. Okay, so if you talk about, yep, so if you, okay, this kind of noise, okay, even if you don't learn median filter, one of the alternative way to remove this noise is actually you can use the averaging filter or average filter, because by applying the average filter into this image, actually you manage to, you know, reduce the strength of the signals, or the strength of the noise, because by smoothing the image, actually you are reducing the strength of the noise. Okay, you are reducing the strength of black dot and white dot, and we can consider that average filter or smoothing filter is one of the alternative that can be used to remove this kind of noise inside your image. However, that filter or that image enhancement approach is not as good as median filter, because if you can see the effects there, if you apply the median filter for image that affected with this SARS and paper noise, then you can see clearly that you can, by having this median filter, you manage to get a good image where the sharpness of the image remains there. But if you apply the average filter or smoothing filter, you manage to remove the noise, but you also affect the information as well, meaning that the output become more and more blur as compared to the original image. Okay, so that's why if you talk about SARS and paper noise, then median filter is one of the suitable approach to be used to tackle that kind of noise. Okay, so this is just a comparison. Okay, if you having a SARS and paper noise, okay, then one things that you can there's a two way to remove that noise or to enhance the image is by using the averaging filter or by using median filter. So but if you can see the comparison there, okay, averaging filter managed to remove the noise or to enhance the image, but the effects there, the outputs there become more and more blur because of the smoothing characteristic or the nature of the smoothing operation, where it will make the image become more and more blur. So but by having a median filter, you can remain the information or remain the original image, the sharpness of the image, and at the same time you manage to remove the SARS and paper noise. Okay, so if you talk about okay, this one, this example, because this example, okay, this example, even they are using median filter, actually SARS and paper noise, you should, you know, there's some 1 pixels there when we talk about a SARS and paper noise. Okay, SARS and paper noise, if you imagine in matrix here, okay, maybe for example this one dot is black, so maybe this one is 0, the value is 0, and this value is 255, which is white. So this one we can consider as a because this is a black dot here, then you can consider this is paper noise, and this is a white dot here, 255, so this is SARS noise. So that's why they call it a SARS and paper noise. So if you see the image practically, the practical image, then it's look like this. You have 1 0 pixel and 1 255 pixel, a single pixel, okay, a white dot and a black dot. So that's why they call it SARS and paper noise. Okay, so that is a median filter. And another filter that under this category, which is non-kernel based neighborhood processing, is called as a max filter and min filter. So max filter and min filter, it's just a part of, actually you can see that max filter, okay, what is max filter do? Okay, if you go back to these examples, okay, if you talk about the max filter, okay, you will apply, if let's say you want to apply the same example here for you want to apply the max filter. Okay, so if you want to apply the max filter, let's say this is max filter, that is not okay, what you do is you just find the maximum value. Okay, so if you want to apply the max filter, you do the same as median filter, you sort the number into ascending order, and then you choose this value, which is the maximum value, to be put here. Okay, that's just the difference between maximum filter and median filter. So same goes to min filter. So for min filter, what we can do is that, okay, so if you talk about the min filter, then same, we sort the number into ascending order, then we choose the minimum value to be put here. So now that is what we call as a min filter. So that is the difference between median filter, maximum filter, and minimum filter. So as you can see there, maximum filter, okay, if you read through this slide, for maximum filter, we replace the center of the pixel with the maximum value from the neighborhood, and this one is very useful in finding the brightness point in the image. Okay, this one is very effective in removing the paper, the paper noise. Okay, so if your image only affected with the paper noise, which is the black dot, then you can, one of the alternative you can use is this filter, which is a maximum filter. But if your image is affected with sud noise, then you can use a min filter. But if your image is affected with both suds and paper noise, then it's better for you to use the median filter. So actually, median filter, even your image is only affected with paper noise, you can also use a median filter. You can see that median is more powerful than maximum and minimum filter, because the median filter, you are choosing the center. Okay, from the ascending, after you sort the number into ascending order, you are choosing the center. So the concept behind this is because when the sud happen or the paper happen, in general, okay, if you go into this result, for example, okay, again, this is the one that we have discussed before, which is the green ink there. Okay, assume this is a sud noise and this is a paper noise. Okay, and then what happened when you sort this into ascending order? Actually, this will become 0, this will become 255. Okay, in general, the sud pixels will always going to the most left, okay, this region, and then the paper will go to, the paper here. So paper always goes into the minimum value, and the sud always go to the maximum value, or the most right in the set of that ascending number. So in other words, by choosing the median value, you can avoid from having the noise back inside the image, because in general, the median value is always some information. Good, sir? Okay, so that's why by having some value here, and you set into this output pixels here, you are avoid from having a sud paper, or a sud pixel, or the paper's pixels. So you actually try to remove all paper and sud noise inside your image. So doesn't matter your image is affected with suds only, or paper only, or suds and paper, you still can use the median filter to remove all that kind of situation. But if you are using a maximum filter or minimum filter, it's depend on the situation, because let's say if you are using a maximum filter, then you can only tackle the image with affected with paper noise, because when the image is only affected with paper noise, then it's actually most of the time the noise always located at this point. So that's why by having maximum filter, then you can still, this one is still some information, it's not the noise. Okay, but if you talk about suds and paper noise, suds and paper noise, then both most left and the most right set of numbers in ascending value over here, a set of ascending value over here, will always will always occupy with noise, either suds noise or paper noise. So that's why for min filter and maximum filter, it's depend on which noise is affected your. Is it a suds only or is paper only? But for if the image is affected with both, then median is the most suitable, and even median can tackle for image that affected with suds only or paper only. Okay, another things that I will like to remind is that regarding the hand calculation, like I mentioned before, okay, if you have later when you do some activity that I give to you, doesn't matter is it come from the first chapter, second chapter, or third chapter, or any chapter. Okay, again, I would like to remind you that when you calculate something, if you find out that, okay, when you calculate something, and then when you find the final matrix or the final output image is in floating number, okay, please round it into the nearest integers number. Okay, for example, okay, that is also depends on the again intensity level resolution. Okay, if the intensity level resolution is 8-bit per pixels, okay, I just give you, I will like to let's go to whiteboard to discuss about this thing. Okay, let's say the intensity level resolution of the question is 8-bit per pixels. So again, you need to remember, when we talk about 8-bit per pixel, you can only have the value from 0 to 255. So in other words, it should be integers number 0, 1, 2 up into 255. So in other words, if you do hand calculation and you find out that the output image, okay, in form of matrix, again, of course, if we talk about the image is in form of matrix, and you find out the numbers that you calculate here is a floating number, let's say 0.6. So please don't leave the 0.6 in the matrix. You must round into the nearest number. Of course, this one should be convert into 1. Okay, so if you get let's say 11.3, then please round it into the nearest number, which is 11. Okay, and then if you get a negative number, this one I forget to mention in the earlier discussion. For example, you get minus 11. Okay, again, because our range here, okay, again, this depend on the intensity level resolution. For this case, because our intensity level resolution is from 0 to 255, so any negative number, please convert into 0. Okay, same goes to any number which is more than 255. Let's say you get, when you calculate, you get 344, then please convert it into 255. Okay, I hope you practice this one when you do the hand calculation, because any number which is a weird, when I say weird, is out of the range of from 0 to 255, then I will deduct the mark. Okay, so that's why we need to remember, any floating number, please make it as an integer, and then anything negative becomes 0. Anything more than 255, you change into 255. Again, it depends on the intensity level resolution. Okay, if the question have another intensity level resolution like 4-bit per pixels, okay, the range is from 0 to 15. So if you get numbers more than 15, then please convert it into 15. If you get a number, negative number which is less than 0, then please convert it into 0. Okay, if you get floating number like 12.05, then please round it into the nearest integers. Okay, so I hope you clear about this, because we want, this is how actually the programming part works. Okay, when you do the simulation in MATLAB, when the MATLAB gets some certain number which is in floating number or more than the maximum intensity level or intensity value, or if you get negative number, it will automatically convert into the range, that the given range there, or the given intensity level resolutions there. So hope that you clear about this thing.